Okay, we're going to look at energy changes in chemical reactions, an introduction to this topic. Okay, so from your physics, you probably know that energy can't be created or destroyed. It just gets moved from one store to another. On the physics, you go on about a load of different stores, gravitational potential and so on. But the only two stores we're really interested in chemistry are the chemical store and the thermal store. And during chemical reactions, usually what happens is chemical energy is transferred to the thermal store. So that means burning gas, burning methane, you're going to get hot, you're going to get energy given out, and that is called, well, heat given out, I should say, and that's called an exothermic reaction. So it will get hot. Much less frequently, sometimes thermal energy, the energy in the thermal store, is converted to the chemical store, and this is called an endothermic reaction. And if you have an endothermic reaction, you'll notice that it will go cold. Okay, so ice pack sort of thing. You put on a sports injury or something, you break open the pack, the two chemicals react together, energy is converted from the thermal store into a chemical store, so the temperature goes down. Okay, endothermic reaction is much less common. Right, let's have a look at an exothermic reaction then, and how we would maybe do an experiment to have a look at this. So if you get magnesium ribbon and a piece of magnesium ribbon, you put it into dilute hydrochloric acid, it will fizz up, you get hydrogen gas, the magnesium will dissolve to form magnesium chloride, and it will the acid gets noticeably hot. It's really quite hot. It is an exothermic reaction. Okay, so how would you do this experiment? If you want to actually investigate it, you probably wouldn't do it in a glass beaker. You would do it in a polystyrene beaker, because that's a good insulator. Okay, so here's a polystyrene beaker. So the heat can't escape to the outside as easily. You have your hydrochloric acid in there, and you put a thermometer in there. Let's say the temperature at the start, the acid came off out of the cupboard, it would probably be about 18 degrees C or something like that. And then you put in a piece of magnesium ribbon and allow it to react. It will fizz up, and when it's dissolved, you can take the final temperature, and maybe it's gone up to say 30 degrees C. So there we would have a temperature rise of 12 degrees C. Right, let's have a look at this little diagram down here. So I'll just make this a bit bigger. This is an energy diagram, and you'll see these quite a lot. Now, on the y-axis, on the vertical axis there, you see you've got energy, and I've written chemical energy there. Quite often, usually in an exam paper, a chemistry exam paper, they never write chemical energy there, they just write energy, which is a bit confusing because of the total amount of energy, of course, can't change. So the chemical energy of the magnesium and the hydrochloric acid is quite high up here, and when it reacts, you've got less chemical energy. So what's happened to that chemical energy there? Well, all that energy there, that has been released as heat. So you get however many, it's usually measured in kilojoules. You get so many kilojoules of heat energy released, and you can tell because I say the level of the products is lower than the level of the reactants. Okay, now let's have a look at an endothermic reaction that you can do in the lab. And again, as I said before, these are much rarer, and it's quite hard to find endothermic reactions sometimes. So if you get some solid sodium hydrogen carbonate there, and you put that into dilute hydrochloric acid, it fizzes up, you release carbon dioxide this time, you make a little bit more water, there's obviously a lot of water in the acid already, and you make some sodium chloride in solution, and you'll notice if you do this, the temperature goes down. So if you do this in a polystyrene beaker again, You have your acid in there. Take the temperature beforehand. So do the temperature at the start. Say it's 18 degrees C again. Pour in your sodium hydrogen carbonate with white powder. It will fizz up, releasing carbon dioxide. Once it's finished fizzing and the reaction stopped, take the temperature again. And let's say this time it's gone down to 12 degrees C. Okay, so the temperature has dropped by 6 degrees C. So that the thermal energy in the hydrochloric acid largely, okay, which will be most of the hydrochloric acid is dilutes. Remember, it's mostly water. So the thermal energy of the water has gone and it's been turned into chemical energy. So if we look at the reaction profile for that one, here it is. Again, I've marked my vertical axis chemical energy. That's usually not, it just says energy in the exam. But right, so it starts off at a lower level. Here's your sodium hydrogen carbonate and hydrochloric acid. And the products end up with more chemical energy than they started off with. Okay, and you can say that that amount of energy, that is the energy which has been taken in, if you like. This is an endothermic reaction. So that's the energy, the heat energy which has been taken in. And can I just say one thing now before I finish? Endothermic, it's about like 1 in 5 people get a bit mixed up with endothermic, because we know endothermic means it takes heat in. We say it takes heat energy in. So they think it should get hot, okay, because it's taking heat energy, but it doesn't do that because it doesn't really take the heat energy, and that's not the best way of saying it. The best thing to say is the heat energy is converted to, heat energy is taken in, yeah, and it's converted to chemical energy. So in summary, if you have an endothermic reaction, the temperature drops. An exothermic reaction, the temperature will go up.